Welcome to WB Institution, an online educational app. Today we are going to see about bridges. If you consider bridges, we'll be having two different types, means AC bridges and DC bridges. What is the major difference between your AC and DC? The source of power. In your AC bridges, the input power will be your AC, that is your alternative current. What about your DC bridges? The input power will be a DC, that is your direct current. Among your AC will be having some other subdivisions, and for your DC will be having different bridges. Among that will be having a subdivision. Clear? So today we are going to see about this alternative current bridges, which is also called as AC bridges. So before getting into the entire concept, we'll know why we are going for these bridges. What is the major purpose of going for bridges? These are used to measure the unknown factors, unknown electrical factors like your resistance, like your inductance and your capacitance. Okay, these are some electrical factors like resistance, and to measure your inductance and capacitance, the unknown values. Okay, added to this, it has a very convenient feature and gives a very accurate result. The result is very accurate, added to is very user friendly, and it is very convenient. So only we are getting into bridges. This is also used to determine your storage factor, your power factor. Clear? Not only the electrical factors, it also used to measure the storage and the power factor, which is unknown. Clear? This is going to be your basic concept of why we are going for a bridges. Clear? Now you can see the construction of a AC bridge. In this, I have written a Wheatstone bridge. Guys, do you have any idea, is this a AC or a DC bridge? If you know the answer, please write it in the comments. But right now I'll say this is going to be your DC bridge. Okay, Wheatstone bridge is nothing but a DC bridge. Why I have taken this DC bridge in this AC construction is, my AC bridge construction is based on this Wheatstone bridge. In what way? See here, you can see some four legs. Okay, this is going to be your four legs. In that four legs, what you can see a resistor. These are some four resistors. Correct? In between you can see a word called null. It's nothing but a galvanometer. Here a galvanometer is placed. It is used to check the null deflection. Also, it acts as a balancing for your bridge. Clear? Now, the input source is said to be a battery. This is your battery. Okay, this is said to be your battery. The input power source is obtained from a battery where EMF is got induced and the process has happened. Clear? This is said to be your basic concept regarding your DC Wheatstone bridge. Clear? Now, how my AC bridge is constructed on the base of this, you can see here. Again, a four leg you can see. In this four leg, I have noted as Z1, Z2, Z3 and Z4. What that Z implies, it is the impedance. In your DC Wheatstone bridge, you can see the resistor, but over here the impedance means that it has a combination. What is exactly a impedance represents, ma? It is a combination of your resistor, the combination of your inductance as well as your capacitor. That seems to be your impedance, right? So on the four legs, the impedance are got connected, and in between you can see a word called D, a letter called D. That is nothing but a detector. D is nothing but a detector. Clear? This acts as a balancing for your bridge circuit. Clear? Now here you can see a source of power is a AC supply voltage. This is said to be your AC supply voltage. Clear? This is your input power source. Now can you understand why I have taken this Wheatstone bridge as a base? Clear? Fine, this is going to be your entire construction regarding your AC bridge. Now we'll see the source of power supply. How the power supply has been given to your bridge circuit. So in this, I'm going to verify it for two frequencies. One is going to be your low frequency, the other one will be a high frequency. If I'm going to measure it for my low frequency, the source of power will be my power lines. Clear? That will be from a power lines. If I go with my high frequency, it is a electronic oscillator. Clear? In this, I'm going to take a electronic. What exactly an electronic oscillator works as? It is used to transmit a DC current source into a AC. What exactly a DC ma? Direct current into a alternative current. The oscillators are used to convert your direct current into a alternative current. Here the electronic oscillators are used, where these electronic oscillators will make a periodic signals, will give a periodic signals, like the output will be a sine wave, or else it can be a square wave. Clear? Sine wave or else a square wave. These are the output of your electronic oscillator. Clear? For your low frequency, you will be using your power line, and for your high frequency, you will be using your electronic oscillators. This is going to be the power source of your bridges, that is your AC bridges. Now getting back to your detectors, you can see a center null deflection. You'll be having a detector in the center which acts as a balancing for your bridges. In this, we'll be having some three different kinds of detectors. Why these three detectors are present? Why not only one? Why? Because depending on the frequency changes, the detectors has been used in your circuit. Okay, depending on the frequencies, each of my detectors has been used. Each detector will be having its own frequency part. Clear? Now if you consider your headphones, in this the maximum and the minimum frequency which is operating is 250 Hertz. The minimum frequency will be here, the minimum frequency will be 250 Hertz, and the maximum frequency will be 3 to 4 kilohertz. The working part is said to be here. This is said to be a low frequency. At low frequency, this is a high frequency. Clear? Clear. Now considering the other vibrational galvanometer, here it starts from frequency 5 Hertz to 1000 Hertz. Clear? It starts from 5 Hertz to 1000 Hertz, and it also works as a power and low audio frequency. It can be used under a power and low audio frequency. Added to that, here under 200 Hertz, it is said to be sensitive. So it is better to use under 200 Hertz. If you consider under 200 Hertz, the power, the galvanometer, vibrational galvanometer is said to be sensitive. Clear? When you consider your headphones, if you have a single frequency, okay, for single frequency, the tuned detectors are sensitive. For a single frequency, the tuned detectors are sensitive. Clear? This is going to be very important. Fine. Now the third kind of detectors are said to be a tunable amplifier circuit, where the frequency ranges from 10 Hertz to 100 kilohertz. Clear? These are the frequency ranges. Under this frequency, within this frequency range, the tunable amplifier circuit seems to give a better performance. Hope you understand what exactly a AC bridge is. What is the main purpose of an AC bridge? You have read about the detectors. Hope this section would be very useful for you guys. If you have any doubts, or if you require any furthermore clarification, please write your questions in the comments. Thank you.